Hello, it is now time to take notes on using the fundamental identities to evaluate and to factor. You might be like, what? You haven't showed us factoring. Don't worry, it's the same factoring strategies. We're using some identities. So, that was the random thing that poked up on my computer screen. So what we're going to do is begin, so take out your notes, it's divided page, so theoretically this should be a line down the middle, which I can produce for you. So when you evaluate trigonometric identities, given the values of the trigonometric functions, you can evaluate all the other ones. So that means if I give you sine and cosine, you can find tangent, cotangent, secant, and cosecant. And that's what we're going to take our notes on today. So the first thing you would do is to draw a right triangle on the unit circle, labeling all the information. And again, don't label the tangent and cotangent. That would be your last resort. So I'm going to go over here on the side and for this problem and do the step. Find the trig values, given that secant of u is equal to -3/2 and tangent of u is greater than 0. To which case you start to freak out and go, but Miss Anna, you didn't give us one where you just said greater than. Okay, so pause for a moment and let's take a look at this page. No different. Do you remember? Sine is positive. Cosine is positive. Tangent is positive. So assume we go in that same shape. Sine is positive. Cosine is negative because we're left of the center, and the tangent is positive. Sine is negative, cosine is negative, tangent is positive. Sine is negative, cosine is positive, and tangent is negative. Now let's look back here for a moment. Tangent is greater than 0. That means the tangent is positive, so I'm looking at quadrants 1 or 3. All right. And the secant is negative. Secant goes with cosine. So the cosine is negative. Oh, that's right here. Now I know that my triangle is in quadrant 3. Here's my x. Okay. And then I need to label my triangle. Well, sometimes that helps me to find the cosine first. Is the reciprocal of the secant. So therefore it's -2/3. Okay, your hypotenuse will never be a negative. This is 3. Cosine is adjacent over hypotenuse, so this is -2. All right, and so I have the right quadrant. I've labeled what I know, and I have the cosine. The second step is to find the missing side on the right triangle. And you use Pythag. -2 squared plus 3 squared plus x squared equals 3 squared. So doing a little mathy, getting my pen to catch up with me. 4 plus x squared equals 9. Gives you plenty of time to write. You're going to be way neater than me though. So if x squared equals 5, then this is the square root of 5. Now remember, it needs to be a negative given the quadrant location. This is in the negative y values. So therefore I can easily now find my sine. My sine value, I guess I should label these a little bit more because we have 2 c's now. My sine value is opposite over hypotenuse, which is going to be -√5 over 3. If I know my sine, I can also find my cosecant, CSC, by flipping it. A little work on the side, I automatically know it's going to be a negative, but when I flip it, I get this, and I must rationalize. I multiply the top and the bottom by the square root of 5, and I get -3 square roots of 5 over 5. I'd make this a lot neater if I were you on your paper. From there, I'm going to try to find my, and then use the trig identities to find the 6 trig functions. So I got to find my tangent Tangent is opposite over adjacent. Negative root 5 over 2, negative 2, in which case the negatives can cancel. So it is a root 5 over 2, and notice that's greater than 0. My cotangent is the reciprocal of that, which initially would be 2 over root 5. However, I need to rationalize the denominator, and I have 2 root 5 over 5. So the steps again: draw the right triangle. First you got to find the location given your information. Label the triangle what you know and find the missing side. Use the trig identities to find the 6 trig functions. So you want to do reciprocals when necessary, and then go back to basics: opposite, adjacent, and hypotenuse, SOHCAHTOA. Don't worry, we're not quite done. We're going to go to page 2, the second problem. So we're on this problem, so we can ignore this one. I just don't have a ton of room. So one more example, we're going to find the 6 trig values. So again, start by your right triangle. Where is this? Tangent's positive, cosine is negative. Oh, same quadrant. X. And then I need to label it. Remember, you shouldn't label your tangents unless you have no other option. So I label my cosines. This is negative square root of 3. And this is 2. I need to find my third side using Pythag. Because I can't write fast, I'm going to do, this is my workbox. How about that? Alright, so then I have root 3 squared, which is 3, plus x squared equals 4. You can see that x squared will equal 1, so x equals 1. I'm going to put a 1 here. It's negative. Look at its location. So then now I found the missing side on the right triangle. Now I need to find the other identities. Cotangent's going to be easy because cotangent is going to be the reciprocal of tangent. Uh-oh, workbox. 3 over root 3. When I flip it, rationalize the denominator, multiply both by root 3. I get 3 root 3 over 3. Notice the 3's cancel out. So now I get cotangent is equal to root 3. Now I'm easily going to find the secant because that goes with cosine. It is the reciprocal of the cosine. So I'm going to do my workbox. 2 over root 3. I need to rationalize. This one I can do without showing you the extra work. Multiply both by root 3. I get 2 root 3 over 3. Wicked messy. That's why you listen and write too. It's a negative because cosine is negative. Sine, oh no, I don't know sine. Well, I go back to basics. I have a right triangle and I know it's opposite over hypotenuse. Negative 1/2. And sine should be negative in the third quadrant as my double checker. Cosecant would be the reciprocal of it. Flip it around and it is negative 2. Voila, I'm done. Not yet, because you notice your notes continue. So go to the next page. Factoring using the fundamental identities. Use the trigonometric identities first to rewrite the expression if needed, usually getting down to sines and cosines. And then factor as usual. We're still using GCF, difference of squares, sum and difference of cubes, trinomials, and grouping. So this is hard to even get a GCF. What do you do for this example? Because it has cotangents and cosecants. How do I do that? That's when you begin by changing it back to its basics. So cotangent, remember, tangent is sine over cosine. So cotangent is the reciprocal of that. So I'm going to write 2 cosine squared over sine squared. I guess I should put the x in. Just so much more writing. Over sine squared. I'm going to leave out the x's for now, just for time's sake. Plus 3, and cosecant is 1 over sine. So I'm actually going to erase that little thing I just drew. So it's 3 times 1 over sine. So it's 3 over sine. Oh, now I notice they have something in common. They both have at least one sine in the denominator. So I'm going to pull out 1 over sine, and I am left with 2 cosine squared over sine. Oh God, is this messy? Over sine plus 3, because there's no more denominator. And then that would be considered factored. It looks a little messy. Could you simplify 1 over sine to cosecant? Yes, that's where we're going next. Second example, I look at it and I could change it, but something jumps out to me first because it looks just like a difference of squares. So I could say tan minus secant, and then I could do times tan plus secant. Plus secant. Now, what if you had changed it back to basics first? Would it be any different? Probably. So, tangent is sine over cosine. So I'm going to do sine squared over cosine squared. Minus 1 over cosine squared. Do you notice how they have something in common? That 1 over cosine squared. So I'm going to pull out a GCF of 1 over cosine squared. And in parentheses, what I'll have left is sine squared minus 1. Now I can scribble it out. I can continue because that's a difference of squares. So I would do 1 over cosine squared times sine plus 1 and then sine minus 1. Then you go, well, which one do you prefer? At this point, it does not matter to me. You can have multiple answers. You'll see where we're going next, that different paths may be more or less helpful, and it's never the same path that's more or less helpful. So I would accept either answer. Now, the third example, since I ran out of room, oh, that looks like a trinomial, and it's just sines. How beautiful is that? Area model. This is 3 sine squared. This is, when I say this, I guess you didn't know. This is -8. The 2 boxes here need to add to be -2. So I say to myself 3 sine and then sine. And then I change the width to a little bit thinner. See how that helps me. I gotta use a negative and a positive. So I'm gonna put a positive 4 and a -2, because that gives me -6 and positive 4, which add up to be -2. So then I get 3 sine plus 4 times sine minus 2. Sine minus 2. And again, your notes are way neater than mine, right? Over time, I'll get better. I remember when I started writing with my finger on the iPad. I've improved. So my handwriting will get neater, but we have 3 sine plus 4 times the sine minus 2. And those conclude your notes, or that concludes your notes.